tonight in our class today to be a continuation of the previous course, GST 105, Philosophy of Science. Just gonna let you to do a thing and send a link. Alright, let's go straight into it. So, in our last class, we talked about what the processes involved in kind of the scientific processes. We talk about each step, and we talk about the very first step, which is identification of the problem, and we talked about how you can begin with that and break it down and begin to ask questions. We said if you have to go through things scientifically, they must have an inquiring mind. You must ask questions, inquiring things. So we discussed all this in our last class. So today we'll be talking about what theories are in science. So talking about theories in science, we're talking about evolutions of some certain persons, Darwin evolution, the evolution after, then before, and in between. So we have that is that. So without further ado, let's just head straight into it. Okay, so today's topic is taken from Unit 3, which is basic scientific theories. And we have our objectives. We have, what is scientific theory, what the theories of evolution. We have all this. So we live. I think that was a thing from the network, but I think we're good now. So okay, mouse. Yeah. Okay, just trying to fix this my material so you can just head straight at it. So we have the evolution before Darwin, that are the things we'll be looking at tonight. Darwin and modern evolution thoughts. We have evolution after Darwin. So we have the introduction. In our previous unit, scientific method, we discussed about steps of how things are to be done in science, talking about stages. We talked about 6 of them. So we have today, we said based on what we've been talking about, we've agreed that scientific method is a process of acquiring knowledge about nature. Now, we discussed this. Now, if you can recall, the process involves a sequence of steps that is certain, which are observation, problem identification, hypothesis formulation, experimentation, conclusion, and theory formulation. So we have, in the material today, we'll be explaining the detail of what scientific theory means and the list of the basic scientific theories. So we have emphasis in this unit will be on theories of evolution. Now this topic is important because it will expose you to the different views of people, right from the beginning of recorded history. Views people have held right from the beginning of recorded history, about life, how it began, and how the great variety of Earth's organisms, came to be. It is expected that at the end of this unit, you must have been able to achieve the objective listed below, and the objectives are clearly, define what scientific theory is. Now, list clearly 3 characteristics of scientific theory, identify 3 events that led to the revival of discussion on evolution, describe briefly evolution, by natural selection. Now, explain concisely how other fields of inquiry have led to a better understanding of mechanism of evolution. So by the end of this tutorial tonight, you should most have been able to discuss that clearly now. So what is scientific theory? Now we have scientific theory. Would you if you can recall the definition we gave in unit 2, we stated that scientific theory is an explanation about the cause or causes of a broad range of related phenomena, which was said by Taggart 1992. So he gave that definition about theory. He said scientific theory is an explanation about the cause or causes of a broad range of related phenomena. Now, a theory explains how things are related or their common properties. Scientific research. Now, let's take this, please. A scientific theory. A theory explains how things. A theory explains how things are related or their common properties. Now, scientific research using scientific method leads to the accumulation of facts about nature. As the facts accumulate, organizing them into higher knowledge becomes important, becomes imperative. Now, this is because our minds require a rationalized, logical, consistent body of knowledge to help retain and use information. Definitely. This logical, consistent body of knowledge to help you retain, to help you retain information. And this definition was given by Beveridge in 1970. Now, to help in the organization, a working hypothesis is usually required. For you to organize this body of knowledge, you need a working hypothesis. Now, so theory starts as hypothesis or tentative formulation meant to explain the phenomenon under investigation. Let's do that again. Theory starts as hypothesis. When we say tentative in the sense that something that is yet to be concluded. Now, an hypothesis starts from, when we say hypothesis, a theory starts from a hypothesis and tentative formulation. Now, this hypothesis and tentative formulation is meant to what? To explain the phenomenon under investigation. There's a matter you are investigating. There's a problem you're trying to solve. Now, you start by what? By first giving a tentative formulation or giving hypothesis formulation. And let's not forget, we said hypothesis is a reasonable guess. Give reasonable guess towards something, towards a problem. Okay, now let's just move forward. Now, we have when a hypothesis is confirmed through experimentation, it becomes a theory. So could we say then, before a theory becomes a theory, it has gone through some scrutinization, and the stage of that scrutinization refers to that stage of hypothesis formulation or tentative formulation. So we have that as that. Then we can move on. So we have theories take various forms, which may be as diagrams, equations, statistical and propositional formulations. Theory takes series of form. It could come in form of diagrams, equations, statistical and propositional formulations. Now, a theory is formulated in such a way that its range of application is indicated. It is, during the process of formulating a theory, there are varieties of ways whereby you can prove these tentative formulations. It simply speaks about range of application that will or that must be indicated. Now, it is necessary that when a theory is going through scrutiny, it has the range at which it can be applicable as indicated. Please let's take note of that. So we have now theory. Okay, now yes, I think we are going here. So we have every good theory therefore has a predictive value. You should be able to predict the value of a theory. Now it prophesizes certain results. Every theory does that. It buttressing the fact that every theory should have a predictive value. Definitely, that means it has the capacity to prophesy certain results. Now, prophecies scientific prophecies always have a considerate amount of evidence to back them up. Scientific prophecies always will have what? A considerable, because science is based on what you can see. Basically, what you can is not based on spiritual things. It's based on facts. So therefore, it definitely has prophetic features, and these prophetic features has considerable amount of evidence to back it up. Now, additionally, a scientific prophecy does not say that something will certainly happen. It only says something is likely to happen, and with a stated degree of possibility, just like we have probability. The chances that this will happen is 0.5 or 1.5. Now, theories that have proved to be universally valid and have a high degree of probability are called natural laws. What are natural laws? Natural laws are referred to as theories that have been approved to be universally valid and have high degree of probability. So we have that as that. Now you will learn about these in further units. So we have, in conclusion, theories enable us to explain, predict, and control phenomena. 3 keywords. Theories enables us to explain, predict, and control phenomena. Excuse me. They also provide us with a new way of looking at familiar objects or phenomena. The theory of optics, for instance, provide us with a new way of looking at the phenomena of light. Before this theory was discovered, people thought of light in form of patches, shades of color, and so on. With the theory of optics, people's way of looking at light changed. Light is now viewed as a traveling, that's propagation, and this gives room for explanation, explain a wider range of phenomena that the old way of looking at light. Before this theory of optics came, people saw light, or the way and manner people saw, like, referred to as light. They see light as I think I need to close this. Okay. So before that theory came, people saw light as patches, shades of color. But when the theory of optics came, it changed the way people see things. That's what theories basically does. Now, since the advent of modern science in the 16th and 17th centuries, that's Anno Domini AD, many scientific theories have been proposed. Now, these include the theory of universal gravitation, theory of evolution by natural selection, the atomic theory, genetic theory, relativity theory, quantum theory, and so on. A lot of theories have been formulated, since the modern science in the 16th and 17th century. So So we have the theories of evolution will be discussed in the next session. That's what we are focusing on tonight, theory of evolution. So we have evolution before Darwin. Ever since the beginning of recorded history, now we are now in page let's just try and get this off my page 42. Page 42, and we are on 3.1.1, which is the evolution before Darwin. Now, ever since the beginning of recorded history, man has speculated on the origin of life. In ancient times, it was generally believed that organisms generated spontaneously from non-living matter. Thus, the ancient Egyptians believed that rats came from garbage. Renaissance scientists knew better than this, but with the 17th and 18th century AD, it was widely believed that bacterial microorganisms discovered in 1676 originated spontaneously. Please let's take note of this point. Renaissance scientific knew better that rats did not come from garbage, just like the Egyptians assumed or believed. Now, excuse me. Now, it was widely believed that microorganisms, in 1677, in 76, 1676, it was widely believed that microorganisms, originated spontaneously. Now, it was only in 1862 that Louis Pasteur discovered once and for all that theory of spontaneous generation. Now, have you ever wondered how the earth came to be populated by a great variety of organisms? The research for explanation has proven to be challenging. The answers have been found to point to one direction of evolution, which means the progressive change of living things through time. Now, the idea of evolution was not originated by Darwin in the 19th century, as some people think. Raven and Johnson said that the idea of evolution did not originate by Darwin. Now, some ancient philosophers observed that organisms range from very simple to relatively complex ones. Each group of organisms, according to them, was created by God. Now, modern individuals of each group trace their ancestry to the individual created by God. The Judeo-Christian culture also promoted such thinking. Now, most early scientists believed fully that each kind of organisms which are of its individual adaptations were created by God. They studied these organisms, their structures, relationship between them as a way of learning more about the Creator. In the 17th century, for example, the English scientist, clergyman John Ray, 1705, clearly declared his belief that each kind of animal and plant had remained unchanged from the day it was created. All these views are collectively, known as the doctrine of fixed species or creationalism. So now, speaking of the doctrine of fixed species or the doctrine of creationalism, some scientists believe that organisms were created by God. And this is a bit blurry. I think it's better now. Yeah. So we have that as that. So we have speaking about the Judeo-Christians, culture also promoted such thinking. The thinking that organisms are created by God. So we have that as that. So most early scientists believed fully that each kind of organism will always of its individual adaptations was created by God. They studied organisms, their structure. Now, speaking of this set of scientists did believe that organisms were created by God, and this set of scientists are, this set of scientists are called the Judeo, that's the Judeo, Judeo Christians. So we have that as that. So we have let's just move to the next thing. So we have okay, during Darwin's time, biology was dominated by natural theology. Can I take that again? We have during Darwin's time, biology was dominated by natural theology. The natural theologian believed that the various and adaptations of organisms prove that each species was fashioned by God for particular purpose. This is what they believe during Darwin's time. Now, theology influenced a lot of things during Darwin's time. Now, God for a particular besides, they believe that the earth was only a few thousand years old. For them, this was for them, this was not long enough for significant evolutionary change. What is your we have that as that. So do you believe in the theory of spontaneous generation or the doctrine of fixed species? What are your reasons? So the doctrine of spontaneous generation, now let's take note of it. I think we're back. That was the thing from the network. So now, these two doctrines, we have the doctrine of fixed species and the doctrine, we have the theory of spontaneous generation. Spontaneous generation now has to do with organism just coming out spontaneously. But the doctrine of fixed species is said to be that God created some organisms according to a purpose. Gradually, some discoveries led to the level of discussion on the evolution, and this include the discovery of many more kinds of organizations by the first part of the 18th century. Now, the study of fossils, which began in the 18th century by God grace. So now we have, let's just take note of these two. We're able to establish two things. We're able to establish that the theory of spontaneous generation and the doctrine of fixed species. So we have that. So we have Cuvier, more in 1955. Now we have fossils, as you might be aware, are remains. Now talking about fossils now, as you might be aware, remains a body of impressions of dead organisms. Speaking of which, fossils, that's Fossils. As you might think, they are the remains of body impressions of dead organisms that lived in the past. Okay, so we have that as that. Fossils are remains or remains or body impressions of dead organisms that lived in the past. They are usually found within sedimentary rocks which occur in layers. Now, Cuvier, from his studies, this is a scientist, Cuvier from his study found that different layers of the rocks led different kind of fossils. Also, the fossils appeared in chronological order, that is the deeper layer, and older the fossil it contains. Now to Cuvier, this observation seems to be boundaries for dramatic change in ancient environments. His attempt to explain these changes came to be known as catastrophism. So we have that as that. So let's just continue. So now from 1707 to 1788, a French biologist named Georges Lois Comte before studied many mammals and observed that all of them have common features. He then suggested that this could be explained in terms of their evolution from a common ancestors. So let's just take note of the name and the year. The scientists that studied, mammals, and he got to know that many of them has common features. And the year and the name of the scientist is called Georges Lois. Comes there before, and it's from the year 1707 to 1788. Now, we have in 1795 a geologist called James Hutton argued that the Earth was older than a few thousand years. His hypothesis was based on the fact that he believed that sedimentary rocks that encased fossils were formed by the gradual accumulation of sediments in lakes, rivers, and oceans. This idea is known as gradualism. So the word gradualism means, gradual accumulation of sediments in lakes, rivers, and oceans. Now, his explanation indicated that the Earth was millions rather than thousands of years old. Now, that is an hypothesis, and it will take time, it will take some scrutiny for it to become a theory. Now, we have catastrophists. Catastrophists such as Cuvier and gradualists like Hutton and Lille were good geologists. They were convinced of an ancient earth birth. They found it difficult to explain the appearance and disappearance of species. Appearance and disappearance of species in fossil record. So we have I think my material here is trying to close that. Okay, so we have that's a very interesting thing, discovering that a lot of fossils are in rocks. And the discovery definitely changed a lot of things. So we have so Lille in particular attributed the gradual addiction of new species to the Earth's flora and fauna to an unspecified creator. So in 1809, the year Charles Darwin was born. Let's take note of this. Charles Darwin was born in the year 1809. Jane Baptiste the Lamarck proposed that all species, including human beings, are descended from other species. Who proposed that? Jane. Okay, Mr. Jolas, it's good to have you join us. So Jane Baptiste, I think that's the name. Jane Baptiste de Lamarck proposed that all species, including human beings, are descended from other species. Let's take note of that, please. So let's also take note of this, that in the year 1809, Charles Darwin was born. So we have that. So we have so now Raven and Johnson discovered the fact that a scientist called Lamarck proposed that all species, including human beings, were descended from other species. Now, he believed that, who believed, now, we're talking about Lamarck, that Jean Baptiste Lamarck, he believed that life changed progressively from the simple to the more complex. He was the first naturalist to present a unified theory that attempted to explain the changes in organisms from one generation to the other. That's a lot of work from these scientists. And the name of that scientist is Jean Baptist Darwin, said, he's the one that presented, uh, uh, from simple to more. He said life changed progressively from simple to more complex. So he was the first naturalist. He was a naturalist. He presents a unified theory that attempted to explain the changes in organisms from one generation to the next. So now, Lamarck's explanations were based on the theory of inheritance of acquired characteristics, which he propounded. His theory were based on, which theory are we talking about? We're talking about Lamarck's theory now. And his theory were based on what? Inheritance of acquired characteristics. Now, the theory stated that changes acquired during an individual's life are brought about by environmental pressure and internal desires, that offspring inherits in the desired change. The theory stated that changes acquired during individual's life are brought about by environmental pressures and internal desires. So we have as that. So according to Lamarck, he said organs of the body that were used extensively to cope with environments became larger, stronger, while organisms that were not used deteriorated. Now, presently, scientists know that mechanisms he proposed for changes was wrong. Now, acquired characteristics cannot be inherited. So why is he acquired and if it's inherited? That's true. His theory, however, stimulated people's interest in evolution. As a result of this, the stage was then set for acceptance of the much simpler explanation that was developed by Darwin half a century later. So now, Darwin's greatest contribution was the laying of the foundation for an evolutionary theory by noting that species change over time and the environment is a factor in that change. So we have that. That's why we have 3.2.2 now. Now, Darwin and modern evolutionary thought. So we have, in this section, we will learn about Darwin's idea on evolution. His ideas had a great impact on a wide array of human endeavors than any scientific advancements of the past 150 years. Wow, that is massive. That's massive. So we have that of that. Now, his research work, on evolution provide the first scientific explanation for the diversity of life. Its explanation of how evolution works has attracted more controversy than most scientific ideas. This is because it has affected not only science but also philosophy, religion, and human attitudes. Now, Charles Robert Darwin was an English naturalist. At the age of 8, his interest in observing the natural world was manifested. So we're talking about Charles Robert Darwin now. We're talking about him. So we have don't close my phone. My phone's overheating. So we're talking about him. So at the age, he was an enthusiastic about hazarded collector of shell. Hazarded in the sense that it's a risky thing to collect shell as of that time. At 10, its interest shifted to the habits of insects and birds. At 15, he preferred hunting, fishing, and observing the natural world to doing his schoolwork. Wow. At the university, he could not complete the study of medicine because that was not his area of interest. He later graduated from Cambridge University as a clergyman, but was still interested in natural history. Now, at age 22, one of his professors at Cambridge University, which is John Henslow, arranged for him to take part in a training expenditure expenditure led by an eminent geologist. Henslow had earlier noticed and respected Darwin's real interest in natural philosophy. Thank goodness to John Henslow, who had noticed Darwin's interest in natural history. He therefore arranged that he offered the position of naturalist in the ship that they were about to sail in. Now, do you know that right from the 1770s, naturalists had always been posted on all British voyages to distant lands? The aim was to gather more knowledge of nature to add to the score of human, to the store of human knowledge of nature, of human knowledge. So we have that. Now the ship they boarded was called HMS. That's Beagle, HMS Beagle. The main aim of the voyage was to complete an earlier work mapping the coastline of South America. While on the expenditure, Darwin's had changes. He had chances to study many dives, forms of life on the island where they stopped. Near mountain ranges and along rivers. He returned to England in 1836 after nearly 5 years at sea, and he began a long life of study and contemplation. Wow, that is somebody who has passion for what he knows. So we have so now Darwin came back to England. The question that disturbed him was what could explain the remarkable diversity among organisms. Luckily, field observation he had made during the voyage enabled him later to reconcile two clues that pointed to the answer. First, while the coast of Argentina was being mapped, he repeatedly got these trips. He made detailed field observations and collected fossils. He saw for the first time many unusual species, including an armadillo. Among the fossils were remains of the now extinct Glyptodons. Glyptodons were large animals that closely resemble the living armadillos shown in the picture below. So we have Darwin became puzzled and started wondering if both kinds of animal had been created at the same time, if they lived in the same part of the world, and if they were so much alike, then why were armadillos still moving about while the Glyptodons were long gone and buried? These are questions Darwin were pondering on. Now, nothing else in the world resembled either animal, although nobody, including Darwin, had ever seen one species evolve into another. He later wondered whether armadillos were descendants of Glyptodons. Second, he had observed that populations of similar kinds of organisms that lived in different geographic regions often show remarkable differences in some of their traits, that is, characteristics. Now, for instance, Darwin saw that giant land tortoises on the Galapagos Island, which were off the coast of Ecuador. Galapagos Island is off the coast of Ecuador. To his surprise, all the tortoises were not identical. It was recorded that even natives of this island and the sailors could tell which island a particular animal had come from. Wow, that's interesting. So, just by looking at it, Darwin reasoned that perhaps all these species descend from the same ancestral form and had became slightly modified after they became isolated on different islands. Now, Darwin again wondered how such modification could occur. He got a clue from a book published by Thomson Malthus in 1978. The title of the book was Essay on the Armadillo. Armadillo Glyptodon, Principle of Population. According to Malthus, any population tends to outgrow its resources and its its members must compete for what is available. This statement struck Darwin, and he thought about all the populations he had observed during his voyage. He thought about how the individuals, members of this population had differences in body size, form, and other traits. It then dawned on him that some traits could lead to differences in the ability to secure scarce resources. So we have that. So as we discussed, Darwin got a clue on how modifications could occur from Thomas Malthus' essay on the principle of population, which that clue Darwin declared that it was natural selection, that it's nature selecting the fit and rejecting the unfit. We have the process of natural selection as follows: selecting the fit and rejecting the unfit. So if there were struggles for existence within a population, then individuals that possesses superior physical behavior or other attributes might have an edge in surviving. Oh, Mr. Fred, it's great to have you join us. I'm surprised you actually got to know of the channel and you got to know of the course. It's been a while. I think that Mr. Fred from Mr. Fred, I know it's one of these African countries. It's great to have you join me tonight. Okay, I think. Yeah, and Mr. Fred, it's great to have you join us. That's one of my good friend. He was doing his masters in African University of Science and Technology, where I was working in the cafeteria there. We had great time. We had good time together. We played football together. We had a great time together playing football and the likes. It's good to have you join us tonight, Mr. Fred. I would appreciate you. I think maybe after the class, I think in the link to other videos of mine, you can find my WhatsApp number there. We can still talk on a more personal note. Thank you for joining us, Mr. Fred. So we have all these put into consideration. Darwin published his book. After he had gathered all this knowledge, all this observation as a naturalist. So he published his book in the year 1859, and his book caused an immediate sensation. Many people were people had been fed a lot of different things entirely. But Darwin took his time after he went on this voyage. I think we are back. The connection is pretty bad tonight. So he was able to gather all this experience and all this knowledge, wrote a book, and he published this book in the 1859. And immediately, this book caused an uproar, caused a sensation. Now, many people were disturbed because the theory implied that human probably evolved from apes, monkeys, and etc. So we have since all share similar characteristics. Surprisingly, in 1858, Darwin received an essay from a young English naturalist named Alfred Russel Wallace. So now the essay was on theory of evolution by means of natural selection. What a coincidence! Both of them had independently reached the same conclusion about evolution. So now let's take note of this. Darwin and Alfred had something in common. Both of them had independently reached the same conclusion about evolution. However, Darwin was given the credit of propounding the theory because of the amount of evidence he marshaled out. Definitely, I think we have little information about Alfred, but from what we've studied about Darwin, it took him years, before he could now before he could communicate his experience and everything he had gathered about his research, about his theory and before it then became what caused a sensation. Thus, Darwin's issue of evolution is one of the main unified themes of biological science. Now, it provides an explanation for three main sets of facts about life on Earth, which are observed: one, the incredible display of different types of living things we see about us; two, the different degrees of likeness among living things. The likeness could be anatomical or molecular. And we have three, the fossil record that shows a sequence in kind of organisms that will live on Earth over billions of years. Now, at the heart of the theory of evolution is the concept of natural selection. Let's take note of this. At the heart of the theory of evolution is the concept of natural selection. Now, this means natural selection is the mechanism that results in evolution. The mechanism that results in evolution is referred to as natural selection. However, Darwin's theory still faced a crucial test which worried him. It did not explain the mechanism of heredity, that is, the way desired traits of characteristics were transmitted to offspring. You will read about the solution to this problem. Definitely we'll talk about it in subsequent sections. So we have so evolution after Darwin. All this we have been talking about is the evolution before Darwin. We talked about the evolution before Darwin and the one Darwin propounded, and now after Darwin has done his own part of his own quarter of contribution, and he had left. So we have before Darwin's death in 1882 and even after his death, many important discoveries have been made, and these have led to a better understanding of the mechanism of evolution. Now, these discoveries were made in other fields of inquiry, such as the paleontology, genetics, biochemistry, embryology, we have geology and ecology. Now, you will learn about the control of these fields, of the first three fields in this section. The first three fields are paleontology, genetics and biochemistry. So now, Darwin, before his death, predicted that fossils, let's not forget, we talked about fossils are the remains of like a prehistorical existence of some life. Now, records should yield intermediate links between the great groups of organisms. Now, I believe you know the great group of organisms. They are fishes, amphibians, reptiles, birds, and mammals. Now, the paleontologists, those who study fossils, who are the paleontologists? They are those who study fossils. Confirmed this prediction 2 years after Darwin's book was published in 1861. An early bird reptile called Archaeopteryx was discovered. It resembled reptiles and birds. You can imagine a bird looking like a reptile. Anybody can imagine. I can't even imagine how that would look. This is shown in figure. Okay, let's see. We have a figure. Okay, here is the bird. A bird that looks like a reptile. If you have the material, it's on page 50. That's a soft copy. We have two images, about three images actually, but split on split into two places. So a bird that looks like a reptile. So we have called the archaeotype. Was the bird was discovered. It resembled reptile and bird. Okay, now like fossils of small two-leg reptiles, it had teeth and a long bony tail like modern birds. Its body was covered with feathers. I hope you guys will not be asked to spell the name of this bird, or you guys will not be asked. I just believe you should come out in your objective. This should not be a objective question, because I'm not sure anybody can put this spelling of. It's about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. About 13 words. Spell the name of this word. 13 alphabets. I beg your pardon. So we have discoveries of microscopic forces by by paleontologists have extended back the knowledge of history of life on Earth, to more than 3.5 billion years. We thank God for microscopic effects. The discovery of other forces has shed light. Well, how do we even get to know of dinosaurs and all these creatures, if not for all these guys, all these scientists that are looking back into what our ancestors and the likes have existed in, the world they existed in. Now, the discovery of other forces had shed light on the way in which organisms have evolved from simple to complex over the course of this enormous time span. The evolution of major group of vertebrates and their relationship to another have become reasonably well understood since bones and teeth were often seen in fossil record. Don't get rotten actually. Among the most important developments in evolutionary biology since Darwin is the application of genetics to the theory of evolution by natural selection. Genetics is the science of inheritance. There's of that. Dash is the science of inheritance. Genetics. If you would recall what we say, Darwin was worried about his history, about his theory could not explain how parents pass on the characteristics to offspring. Now, in the early part of century, that's Gregor Mendel's law of inheritance were discovered. Scientists found that those laws accounted for the origin of new variations in organisms and how these variations were passed from parents to offspring. Now, biochemistry in the science that examines, biochemistry now is a science that examines the chemical processes and substances that occur in living things. Let's take note of that. Biochemistry is a science that examines the chemical processes and substance that occurs in living things. Its techniques are being used to understand evolution better. You would know how this is done. Samples of this same kind of proteins are obtained from different organisms. Then biochemistry tools are used to determine the sequences into acids, in this protein sample after a protein has been extracted from. Okay, Mr. Fred, it's great to have you. Good to have you. I hope we get to talk later. Thank you very much, Mr. Fred. So we have biochemical tools are used to determine the sequences into acid, these protein samples. Individuals, populations, species, and larger groups have sequences, that has characteristics of them. When sequences are compared for, let's say, 10 different species, the degree of relationship can be specified precisely. So we have now the following information might interest you very much. An international team of scientists from Australia, Great Britain, and the United States found that human evolution is still operating according to the forces of natural selection, which was first identified in Charles Darwin. First identified by Charles Darwin. Can you imagine? About how many millions of years ago? Now, the main finding of this study are: 1. Natural selection is leading to women to have the first child earlier in life. This tendency is partly inherited. As a result, evolution is leading to an increasing biological pressure on humans to start families earlier than later. Wow. In the study, Miss Justina, is going to have you join us. He came pretty late tonight, but it's never too late than it's not too late. It's never too late than never. Or how do they say that stuff? Whatever. Now, in the study, Roman Catholic women are found to have a 20% higher reproductive fitness than women of their other religion. Now, university-educated women, on the other hand, had 35% lower fitness than those who left school earlier. The study, however, found that such cultural influences could not explain all reproductive differences between women. So we have that as that. So we've spoken about a lot of things tonight. We're speaking about the voyage of Darwin, a lot of things that have been discovered, and even after him, things were discovered, which is basically the major thing that was discovered after him was basically the genetics, study of genetics. So now conclusion, we've been able to learn that scientific theory really means and what it really means and various characteristics. Now, we have also been introduced to various ideas on evolution before Darwin proposed his theory. Now it is good to be aware that Darwin's theory of evolution, so just like we have, I think there's this question that usually comes out, Father Charles Babbage something. Okay, now let's just have something at the back of our mind. The theory Darwin is known for, is the evolution of, particular theory is the theory of evolution. That is what he's known for. Theory of evolution is the credit goes to him. Now, this is because it explains how life began and how diversified into the organisms of today. If you had thought that human evolution had stopped as a result of improvement in diet, housing, and medicine, you would have pleasantly surprised with the information in this section. So we've been able to talk about the summary of what we've been able to talk about tonight. Scientific theory is an explanation about the causes of a broad range of related phenomena. A theory explains how things are related to their common properties. Theories take various forms, which may be diagrams, equations, statistical or propositional formulations, and the theory is formulated in such a way that its range of application is dictated. Now we have every good theory has a productive value. Theories enables us to explain, predict, and control phenomenon. We have theories also help us with a new way of looking at a familiar object or phenomenon. We have scientific theories include the theory of universal gravitation, theory of evolution by natural selection, atomic theory, relativity theory, quantum theory, and lots more. Theories of evolution propounded before Darwin include theory of spontaneous generation and the doctrine of fixed species of creationism. So events that led to revival of discussion on evolution includes events that led to the revival of discussion on evolution include discovery of many more kinds of organisms by the first part of the 18th century, a study of fossils which showed that layers of sedimentary rocks held different kind of fossils. The fossils also appear in chronological order, and the deeper the layer, the older the fossil it contains. Now, we have Comte de Buffon's observation that all mammals he studied had common feature. Now we have James Hodgson hypothesis that sedimentary rocks that encase fossils were formed by gradual accumulation of sediments in lakes, rivers, and oceans, thus indicating that the earth was millions rather than thousands of years old. The proposition of de Lamarck theory of inheritance of acquired characteristics from Darwin's species of evidence that evolution occurred in the following extinct of species, layers of sedimentary population of similar kind of organisms that lived in different geographical, I think I lost that. Yeah, region often show noticeable differences. So we have that as that. So we have Darwin's got a clue on as to how those modifications could occur from Thomas Malthus. That was what prompted a lot of things from Thomas Malthus' essay on the principle of population. With the aid of those pieces of evidence and the clue from Malthus, Darwin, he declared that it was natural selection is fit. By that, he was able to discover, with the aid of pieces of evidence and the clue from Malthus, Darwin now, from the aid, and pieces of evidence and aid from Malthus, Darwin declared that it was natural selection that is natural selecting the fit and rejecting the unfit. That's what natural selection simply means. That led to the modifications in members of a species. Now, that means that natural selection is the mechanism that leads to evolution. Thus, Darwin's theory consists of two major parts: concept of evolutionary change and the concept of natural selection. Darwin's theory, however, could not explain how desirable characteristics of modification were transmitted as genetics to the apparent offsprings. Now, after Darwin's death, fields of inquiry such as pathology, genetics, biochemistry, embryology, geology, ecology, and so much have produced results that have led to a better understanding of the mechanism of evolution. The field of genetics, particularly through the laws of inheritance produced by Gregor Mendel, has given evidence to how desirable characteristics are transmitted from parent to offspring. So thank you very much, guys. This brings us to the end of tonight's class. So in our next class, we'll have to try to kind of make things faster. Now we have to work on a very fast pace so we can go far. We can cover a wide range of things. Our exam is getting close, so thank you very much, guys. A lot of you guys came late tonight, but all good. You can always come back to the video and watch in your leisure time. Always do well to pick points and make notes out of the video. Thank you very much, guys, and I look forward to seeing you in the next tutorial. Bye.